Okay guys, welcome to AP Calculus, and we're gonna discuss topic 6.8. This is all about indefinite integrals, okay? So finding antiderivatives and indefinite integrals and basic rules in notation. So please be ready with your workbook and so, what is your idea about indefinite integrals? Hmm?
They don't have a.
Say it loud.
They don't have a what's it called? Like they're infinite. Like they don't have
The intervals, right? So no intervals or no limits from A to B. So we have, first we're gonna review, find the derivative of each function. We all know finding the derivative, it's gonna be the power to be written where? At the front, right? And then the power decreases by 1. So we say this is f of x is equal to x squared. So the derivative would be f prime of x is equal to 2x. Okay? Derivative of a constant is 0. Clear, guys?
Yes.
Okay. So next, how about this one? Same thing. Derivative. So f prime of x is equal to still 2x. And how about this one? It's the same thing. F prime of x is equal to 2x. That is derivative, right? So derivative rule, the power decreases by 1. The power to be written right there in front as a coefficient of variable x, and then power decreases by 1. Since power is 2, 2 minus 1 is 1. So we don't have to put 1 anymore as the power. Any question? Pregunta, guys. No pregunta. Okay. Okay. Next is, what is antiderivative of 2x? So we all know that antiderivative is we are adding the power by 1, and the new power is the divisor. Did you get me? So take a look on this one. But first, what is the antiderivative of 2x? And we're gonna have to find the general solution. Now once you have plus c, okay, this is general solution. Now look at this. This has a constant plus 1. So from general solution to, what do you think? It's gonna be, huh? What else? From general to a particular. So this is particular solution. Okay? See the difference now? General solution, that has plus c. Particular solution, it has plus a constant number. So we identify the constant, right? We identify the constant. But for general solution, we don't care. We just put plus c. Any question? Okay, so remember to do antiderivative from 2x. Doing antiderivative, the power increases by 1. Remember, this 2x is understood to be, has a power of 1. Do you get me? And then what do we do if it is antiderivative? The power is added by 1. So added by 1, that means the power now is, the new power is 2. And then what we do with the new power?
Divided.
Make that as a divisor.
You're doing this, Eddie. You're doing it.
Divided by 2. So what happens to 2 right here?
Cancel.
The 2 cancels out. So what is left now is x to the power of 2. That's right here. And then plus constant number, since this is general. Okay, general solution. Here now, guys. Okay. And same thing in here. Okay. So integrals without a boundary are called indefinite integral. Without boundary. So can you write it down? Indefinite integral. In the past, we've been working with definite integrals where the boundaries are given for the area under a curve. Now, we will work with indefinite integrals, which means we are finding the antiderivative as a general solution. General solution. So what is your idea again with general solution? It has plus C. Plus C all the time. General solution. Okay. But for a particular solution, we're gonna solve for the value of C. Okay? So, oftentimes in the actual AP, they just say, find the general solution. So, what comes in your mind if it says, find the general solution, your final answer has to be plus C. Okay? But if the question is says, find a particular solution, that means you're gonna solve for the constant. You're gonna plug in whatever it is. Okay? Clear, guys? So, shall we put this up? So, this is exponential, right? The antiderivative of the exponential e to the power of x dx. Now remember, we are on general. Why general solution? This has no boundary, no limit. Okay? So that means we expect that our answer should have plus C on the last part. You get me? Okay. So this one, the antiderivative of e to the power of x, since doesn't change, e to the power of x. So we have e to the power of x.
6, 7.
So e to the power of x plus a constant. Any question? That's for exponential. Now, what is the difference between e to the power of x and e to the power of x? To identify this one, this is exponential while this one is logarithm. Okay, guys? The a to the power of x is logarithm. Okay? E to the power of x is exponential. So, but if I write other letter aside from a, I'll just say n to the power of x. That is still logarithm. Okay? But commonly used for logarithm is a. So, which means if this is logarithm, we're gonna do natural logarithm. 1 over the natural logarithm times the derivative of a to the power of x, which implies that this is 1 over ln a, natural logarithm of whatever is the base. Okay, ln a times the derivative, which is a to the power of x. So a to the power of x. Since this is general solution, so we say plus c. Okay, plus the constant. Can you write down the constant, so plus the constant. Okay, let's take a look on example number 1. Find the general solution. What is 7 to the power of x? Is it exponential or logarithm? Logarithm. Why? This is base, right? Base. But for exponential, it is always expressed in e. Okay? So, this is what comes in your mind. This is what? Logarithm. So, how we do it now?
Good examples.
We have 1 over ln, right? Okay, can you write down ln 7? So, ln 7, the base, times, okay, 7 to the power of x, plus the constant. Okay, or you may rewrite this as 7 to the power of x over ln 7 plus the constant. You can write it that way. Now, what's the fastest way of doing it? Can you do mental math without passing this right here? Now look, 7 to the power of x. To save time, especially in the actual AP, we're gonna save time. Okay, so just copy this down, 7 to the power of x over ln 7 plus c. That's it. Rather than doing 1 over 7, it's just the same. Do you get me, guys? Remember, we are going to save time.
I like saving time.
Our best enemy in the actual test is the time constraint. So we're gonna have to make it as fast as we can. Okay, this is correct, but it takes a while. So when you come across with this, when you see, especially if this is multiple choice, you go to the options right away. Okay, now can I delete this one? I'll give you one more example. If I give you this one, can you give me right away? I need you to do it quick. How about this one? Find the general solution. What is your answer? 3 to the power of x over ln 3 plus c. Okay, guys? Okay. So, again, this is 7 to the power of x over ln 7 plus the constant. Okay. Now, moving on to number 2. Remember, this is derivative already. Okay? So that means we're gonna do anti. We're gonna go back to the f of x. But it says right here, find a particular solution. So, what comes in your mind if the question is particular solution? Does it has a value of c? Yes or no? Does it has a value of c? Yes, because our concern here is to solve for c, to make it particular solution. Okay, guys? Okay, but what is asked? We're gonna have the condition f of 0. So if x is 0, the function is 4. Okay? If x is 0, the function is given as 4. That means what comes in our mind? We're gonna equate into 0. Right? After equating to 0, replace that 0 into f of 0, which is 4. Okay? So, we now say f of x e to the power of x. Okay? So we have e to the power of x. So it's equal to e to the power of x minus, we are doing now the antiderivative. Remember, the antiderivative of e to the power of x is the same thing, e to the power of x. Do you get me? What about this one? Shall I write here first 2x to the power of 2 and then do the antiderivative? Remember, this is derivative. What is antiderivative? 2, the power increases by 1. So what happens to the power? The power becomes 3 over 3. The new power, right? So this is it. You write it down right here. Okay? Can you write down the antiderivative now? Okay? So this means 2x to the power of 3 over 3. Okay? And then plus the constant. Plus the constant. Now, what is the condition? That f of x is 0. That means, look at this. F of 0, what we do? That means we plug in the 0, right? So from e to the power of x into e to the power of 0. And then minus 2 times 0 to the power of 3 over 3 plus the constant. And then what does it say? F of 0 is equal to 4. But what is this? What you notice?
0.
This is 0. What you notice in here? This is 1. E to the power of 0 is 1, right? Okay. So, can I continue right here? So, what we do, since we already have f of 0 as 4, so what we write is 4 is equal to e to the power of 0, which is 1. Okay, I have the intention why I write this here first. Okay, I'm doing step by step. So plus the constant. So 4 is equal to 1 plus c. What you do with that 1? Of course, we're gonna subtract both sides by 1. So what is the value of the constant? 3. Constant is 3. Okay, guys. The constant is 3. So what is our final answer now? You're gonna have to write the 3 right here. Replace c with 3. So our final answer, f of x is equal to e to the power of x. So e to the power of x minus 2x to the power of 3 over 3 plus 3. This is now a particular solution because it has a value already of the constant. Do you hear me, guys?
Yeah.
Okay. Can you box your final answer? Need you to box your final answer. Okay? So again, you need to be careful of the question. Find the general solution or find a particular solution. Once the question says find a particular solution, you have to solve for the value of c, the constant. Okay? Careful with that question. What to find? Particular or general? Okay. Can I move this up now? You guys done copying? Okay. So for logarithm as the answer. Suppose we have to find the antiderivative of 1 over x dx. Remember, this is still the 1 over x is ln, right? ln. So, which means this is the natural logarithm of the absolute value. So, ln absolute value of x. Okay? Then plus the constant. Plus the constant. But before I continue this one, can you please write this on the left side of your workbook? I just put number 1, that the integral of e to the power of x dx is equal to e to the power of x plus constant. You need to remember that one. Number 2, I have prepared like 12 formulas right here. The integral of a to the power of x dx. So what is that now? A while ago? A to the power of x. That is 1 over ln. Right? So 1 over ln a times plus the constant. Okay, formula number 3. The integral of 1 over x dx. So we have ln absolute value of x plus c. So this is now formula number 3, right? Okay, moving on to formula number 4. But this is not common to you, or this is already familiar to you. The integral of cosine x. You know what to do. Remember last topic that we had? You do the mnemonic device. Do the antiderivative. If cosine is right here, where is the antiderivative? It goes up. So it's going to be sine. Right? So sine x plus the constant. Formula number 5. The integral of sine x dx. So sine is 90 degrees, right? So antiderivative, do counterclockwise direction. What is that? Negative cosine, right? Negative cosine. So negative cosine x plus the constant. Next, formula number 6. The integral of secant square x dx is going to be tangent x plus c. Okay, can you copy down first the first 6 formulas? Or shall I continue number 7 right here? Are you guys okay? So I'll do number 7 right here. Formula number 7 would be the integral of secant or cosecant x and then cotangent x dx. Can you still recall that cosecant is letter C? Can you still remember what did I say last time? All C's are positive, negative. Huh? All C's are negative. Remember? Okay, that means negative. Okay? Because this starts with letter C. All C's are negative. Okay, so which means negative cosecant x plus c. Okay? Next, formula number 8. The integral of secant x times tangent x dx. Okay. So the integral of secant x tangent x is equal to secant x plus the constant. And number 9, the integral of secant square x dx. So secant square starts with letter C. All C's are negative. So this means negative cotangent x plus the constant. Okay, can I erase this side so I can continue number 10?
This one, it's alright. That looks fine.
Okay, can you still remember the inverse, the trig inverse, the derivative of sine inverse? Can you still remember? And I have it here.
Sine inverse negative cosine. Oh, 1 over radical 1 minus x squared.
What is that? Sine inverse 1 over. Oh, what happened? Oh,
For this one. For this one. This one I got. For H. Close.
Close, guys. Okay. Sam, can you click share screen? Okay, right here.
7 to 0.
Thank you, Sam. So number 10, right? Sine inverse of x is equal to 1 over square root of, what is that, guys? Square root of 1 minus x squared. So 1 minus x squared. Okay, so formula number 11. We're gonna have the secant. be secant, guys.
But
Absolute value 1 over the absolute value. Okay? So it's gonna be 1 over the absolute value of x times the square root of x squared minus 1. X squared minus 1. And formula number 12, I'll give you the tangent. So the derivative of the tangent inverse of x is equal to, what is tangent? 1 over x squared plus 1. So 1 over x squared plus 1. We need these formulas in this topic, guys. Formula 1 up to 12. But number 10, 11, and 12 is not new to you. We've been discussing this in the inverse trig functions. Okay? Okay, shall we continue now on number 3? Okay, so moving on to number 3.
wait, whoa. Wait, Mr. Roy, Mr. Oh, my.
Huh? Are you done?
Yeah, I'm done.
Believe you needed that.
Did you get it?
How about this one, guys?
I gave it to. I got him.
Yeah, I got it.
Okay.
Thank you, Mr. Roy.
So we have the integral of 1 minus 5 over x
It was
dx.
McFeast.
So
I don't think he said it.
No, it's Wednesday.
can we rewrite 5 over x into 5 times 1 over x? Because we all know that 1 over x is natural logarithm, right? Okay. So we now say we can rewrite into the integral of 1 minus 5 times 1 over x dx. Okay? The question, why I am rewriting that one? Because our concern is the 1 over x, which is natural logarithm, right? What is 1 over x? It's gonna be ln absolute value of x. Do you get me? Okay? But what is 1? Constant. That means increases by x. Do you get me, guys? Increases by x. So therefore the antiderivative of a constant is x. So this is x minus 5. And what is 1 over x? Natural logarithm. Absolute value of x. That's the reason why I rewrite. For you to be guided. Okay? Because if I don't rewrite, Mr. Roy, you crack my head why you write 5 ln x. So I do it this way, step by step. But this is only for today's discussion. But next time, I need you to do it quick. You don't have to write 5 times 1 over x. Okay? So, plus, this is general. So, plus constant. So, this is our final answer. So, for number 4, this is similar to problem number 2 a while ago, right? given f of 1. F of 1, the y value is negative 7. But what we do with this? Can we rewrite first before we take the antiderivative? Yes or no? Okay, let's have f of x is equal to, can I write 2 times 1 over x? So you can see right away that it's natural logarithm. How about 6 over x to the power of 2? We can also rewrite this by bringing this x squared up. So, which means negative 2. Okay? So what is asked? To find a particular solution. That means we are solving for the value of c. Okay. Are we good? Is rewriting helps you a lot understand what's going on. We're gonna rewrite it this way because this is natural logarithm of the absolute value of x. Okay? So we now say from f prime of x, we do the antiderivative. That means we go back to the original. Okay? So this is now f of x. Do you get me, guys? From antiderivative, from derivative to antiderivative, we go to the original function now, f of x. As I said, our basic concept is I drop that glass, so the glass was disintegrated, and our next concern is to make the glass into its original shape. So, which this implies to natural logarithm of the absolute value of x. Am I right, guys? And then, how about this one? How about this one? The power increases by 1. Okay? So this means 6x negative 2 plus 1 is negative 1 over the new power negative 1. Okay, plus what? Plus the constant. Okay. And then, what we do with this? Can we bring this down? Can we bring this down? So, we have f of x is equal to 2 ln, the absolute value of x, minus 6, and then times 1 over x plus the constant. Okay, guys. And then what does it say?
ln x.
F of 1. We're gonna plug in 1, right? Okay, and then what is the f of x now equal to? The f of x is equal to negative 7. Okay, so can I erase number 3 so I can continue right here? So for this one, we have f of 1. F of 1, which means we are plugging in like 2 and then natural logarithm of 1. Okay, minus 6 times 1 over 1 plus the constant. Let's simplify this first. So what is ln 1? What is ln 1 equivalent to? It's gonna be nada. Okay, check in your calculator. Minus 6 plus the constant. It's gonna be ln 1 is 0, right? So to save time, guys, register that in your mind that ln 1 is always 0, because we don't have to spend so much time recalling what ln 1 is. Okay, so this means if f of 1 is equal to negative 7, we are now writing negative 7 is equal to negative 6 plus the constant. You get me? So therefore, we say negative 7 plus 6 is equal to the constant. So our constant therefore is negative 1. So where to plug this in? Right here. Okay? You can have it right here. Can you do it by yourself now for the final answer? Just plug in the C. What is C? Minus 1 or negative 1. So final answer for this one, f of x is now equal to 2 ln x and then minus 6 over x minus 1. That's our final answer. So this is now a particular solution.
Absolute value.
Any question on problem number 4? So again, as a summary, we're gonna sum it up. Once the question is general solution, for general solution, your answer should have plus C. But for a particular solution, you find the value of C. Okay? Shall we? How much time is left? Do we have enough time? 5 minutes. So, for the next one, I already give the formula, right? Okay. So for this one,
Yeah, but you do 7.
can you find time to write now the trigonometric integrals of this one? So cosine, what is the integration or integral sign for cosine x dx? Sine. So always remember the mnemonic device. The mnemonic device is a unit circle and having this as cosine. This is sine, negative cosine, and negative sine. This is very important, guys, for you to do derivative and antiderivative. So direction now is counterclockwise direction, antiderivative. So if this is cosine, the antiderivative is sine. Okay? So this is now sine x plus the constant. And then the integral of sine x dx. Does this helps you a lot, guys? Understand? This is very important. This is mnemonic device. So, as much as possible, in the actual AP, you can write that at the back of your calculator as you're not cheating, but you're just putting the mnemonic device. It's not cheating. Okay? Just for you to recall how to do the antiderivative and
It's not cheap. Right?
derivative. Clockwise and counterclockwise. Yes, Chris? For that one, I prefer to just write that in an index card. Index card would be okay. They allow index card formula for the trig functions only. But as much as possible, you're gonna have to memorize. Okay, memorize that. Yes, Usway.
I doubt that.
back in the days, like 10 years ago, they allow.
Yeah.
I don't know with this year.
You just
I
can't
don't know
unsee the
how.
card though. You just have to hide it. Yeah.
Just one index card. The important formula on. Okay. So we have sine, counterclockwise.
allowed to take the AP exam after college.
It's gonna be negative cosine. So negative cosine x
Well, I don't even
plus.
want to use that.
So what is secant? It's easy to memorize. Secant square is just tangent. That's it. Okay? So secant square is tangent. Tangent x plus constant. Now, remember the next one. What is that?
Oh, the seats.
Okay? So, must be negative. Okay? So, negative cosecant. This is how you memorize. The first is cosecant, therefore your answer is cosecant.
Oh.
But it's gonna be negative. Cosecant x plus the constant. Okay? Once you encounter cosecant x times cotangent x, just focus on the first product, right? Product. Just focus on this, but make that as negative. That's how I memorized back in the days in my engineering class. Next, secant tangent. What do you think? The first is just secant. So secant x plus the constant. And next, if this is a square, so that gives you cotangent, negative. Okay? This one is only cosecant x, right? Times cotangent. But this one, cosecant x squared, is negative cotangent x.
Did you turn
So we're gonna continue the discussions tomorrow, guys. Miho, can you?